So we're going to start section 5.3, which is about definite integrals. And so we're going to start with a definition. So what is a definite integral? We'll say the definite integral of the function f from a to b. The way we write it, it's denoted the integral symbol from a to b, f of x dx, and this is going to be equal to a where a, this capital A, is the area of the region bounded by the graph of f the x-axis and the vertical lines x equals a and x equals b. So by definite integral, we're talking about area under the graph of your function like we have been recently. So let's look at an example here. So an example, let's say I want you to sketch the region corresponding to each definite integral. Then what you need to do is evaluate each integral using a geometric formula. So first one we're going to look at, a, the integral from 1 to 3 of 4 dx. So if you look, here is our function y equals 4. Well, that's just a horizontal line. So first we want to sketch our region. Here's y equals 4. And then look at your bounds on your integral. The number here and the number here starts from x equals 1 to x equals 3. Those are going to be vertical lines. So what's the region that I'm talking about here? It's this region I'm shading in right here. And that is just a rectangle. So what's the area of a rectangle? The area is length times width, or the 4 times 2. The side length is 4, the side length down here is 2. So 8. All right, let's look at another one of these. B, the definite integral from 0 to 3, and the function will be x plus 2 dx. So the function I'm looking at, again, in here, y equals x plus 2, and you can graph that. It's a line. 2, 1, it's 3, 2, it's 4, and 3, it's 5. There's my line. And I'm looking where x is between 0 and 3. So those correspond to my vertical lines. So I have 1 on the y-axis, x equals 0, x equals 3. So the region I'm looking at finding the area of is this region right here. And if you kind of flip it sideways, you'll see that this is a trapezoid. And so the area of a trapezoid, it's 1/2 the height, which is 3. That's this length over here. It's the height. And then you add your two bases together. So this length is 2, and that length is 5, times 2 plus 5. So you get 21/2 over. That's going to be your area. You could have also found this area. If you break it up, you'll see that you have a rectangle here and a triangle here. You could add up those two areas and you'll get the same number. And look at one more. So see the integral from -2 to 2, the square root of 4 minus x squared dx. So here my function is y equals the square root of 4 minus x squared. So let's rewrite this function. If I square both sides and add the x squared over, you'll see you have the equation of a circle, but this isn't actually the entire circle. Circle centered at the origin of radius 2. If you look back at your y equation, y is in terms of a square root, so the y is only positive, and so it's only going to be the upper half of a circle of radius 2. So here's my region. X goes from -2 to 2. According to my bounds here on the integral. And so it's half of the area of a circle, so it's 1/2 times the area of this circle, which would be pi r squared. So it'll be pi times 2 squared, or 2 pi. So that's the area of the shaded region.